Let's animate Winston using the shortcuts that you just learned. So here we've got Winston with his eyes, and we've got this eye size variable. So if we wanted to make Winston's eyes get bigger, we could just say eye size plus equals 1, adding 1 pixel to the size of the eyes each time. And whoa, look at it, it's bugging out. Let's restart. Whoa, bug out, bug out, bug out. Now that's pretty cool. And it turns out in programming, we actually add 1 to variables a lot. Maybe while animating, but also you'll see there's a lot of other reasons why we add 1 to variables later. And programmers got bored of writing plus equals 1 all the time, because programmers get bored of silly things. So they came up with a shorter way of writing it. So instead of eye size plus equals 1, we could just write eye size plus plus. And you see, it will do exactly the same thing. It's just a shorter way of doing it. And not only do we use this for programming, now most programmers just use it in everyday speech, because pretty much we're all familiar with this plus plus, and it's an easy way of saying that you're making something a little bigger. So if we went to Winston's birthday party, we might say, oh, happy birthday, Winston, Winston plus plus, because Winston just got a year older. Or if we just learned a new fact, we might be like, oh, go us, intelligence plus plus. And that's pretty fun. So when should you use plus plus versus plus equal? Well, I think actually for animation, it's cool to use plus equal, because then you can use a number scrubber, and you can be like, whoa, let's make it, whoa, that was awesome. Let's make it really crazy, really different. Whoa, see how fun that is? But, depending on what you're doing, it might be convenient just to say plus plus. And you'll see later that there's lots of other times when you might want to add 1 to variables, not just for animation, where that plus plus operator could become even more useful. So just keep that in mind when you see that plus plus, and try using it in your everyday speech. Let's animate Winston using the shortcuts that you just learned. So here we've got Winston with his eyes, and we've got this eye size variable. So if we wanted to make Winston's eyes get bigger, we could just say eye size plus equals 1, adding 1 pixel to the size of the eyes each time. And whoa, look at it, it's bugging out. Let's restart. Whoa, bug out, bug out, bug out. Now that's pretty cool. And it turns out in programming, we actually add 1 to variables a lot. Maybe while animating, but also you'll see there's a lot of other reasons why we add 1 to variables later. And programmers got bored of writing plus equals 1 all the time, because programmers get bored of silly things. So they came up with a shorter way of writing it. So instead of eye size plus equals 1, we could just write eye size plus plus. And you see, it will do exactly the same thing. It's just a shorter way of doing it. And not only do we use this for programming, now most programmers just use it in everyday speech, because pretty much we're all familiar with this plus plus, and it's an easy way of saying that you're making something a little bigger. So if we went to Winston's birthday party, we might say, oh, happy birthday, Winston, Winston plus plus, because Winston just got a year older. Or if we just learned a new fact, we might be like, oh, go us, intelligence plus plus. And that's pretty fun. So when should you use plus plus versus plus equal? Well, I think actually for animation, it's cool to use plus equal, because then you can use a number scrubber, and you can be like, whoa, let's make it, whoa, that was awesome. Let's make it really crazy, really different. Whoa, see how fun that is? But, depending on what you're doing, it might be convenient just to say plus plus. And you'll see later that there's lots of other times when you might want to add 1 to variables, not just for animation, where that plus plus operator could become even more useful. So just keep that in mind when you see that plus plus, and try using it in your everyday speech.
Let's keep exploring what we can do with objects. We're back with a program that we used in the functions tutorial. This program has this draw Winston function, which knows how to draw Winston at a certain x and y. And then down here, we call draw Winston 4 times, each with a different set of x and y coordinates. Well, you know me. When I look at those 4 draw Winston calls that are so similar looking, all I can think about is how much better it would be if we could use a loop and just call it 1 time inside the loop, changing the x and y in each iteration of the loop. So to do that, we need to find a way to store these x and y positions in an array so that we can loop through it. Well, we have 2 sets of values, so what we could do is have 2 arrays, one for x positions and one for y positions. So x positions, we might have 99, 294, 101, and 294. And y positions, we'll have 117, 117, 316, 316. Okay, and now we can loop through those with our for loop, var equals 0, I is less than x positions dot length, I plus plus. So we're going through each element in x positions, and we'll say draw Winston, x positions, i's, and y positions, I. Okay, so let's see if that worked by deleting. All right, that worked. So now we can actually just call this, we just have this one line of code that does draw Winston, but it does it for every position in the x positions array. So we could go and add more to this by saying like 10, and then we add 1, and then we add 1, and then 1, and then 100, and 1. Now it's getting to look a little bit messy, and I don't like it because it's really hard for me to see which x's relate to which y's. I want to kind of be just able to look at a glance and know what my XY pairs are, instead of having to make sure that I perfectly line them up above each other, like this maybe. So I want to find a different way of storing these positions. Now, one idea is that we could actually store them as objects, because think about it, each position is really 2 bits of information, the x and the y. So we could have an object which has x and y properties, and then we could have an array of objects with all these x, y positions. So let's do that. We'll say var positions equals, and this is going to be an array as well, but each element, instead of being a number, is going to be an object. So here we have our curly brackets, and then we're just going to say x, 99, y, 117. Okay, so now we have one of our positions in here, and then we'll go add another one. Oops, add another one here. All right, x should be 294, 117. Okay, the third one is going to be 101, 316. And the final one is 294 and 316. Okay, so now we have an array of objects where each object has x and y properties in it. And so down here in our for loop, we'll just change this to iterate through positions.length, and then we'll pass in the object. Now, right now is passing the entire object, but we want to pass the x and the y. So we need positions I.x and positions I.y. Ta-da! Now we can get rid of these old clustered arrays. Great. So this looks a lot nicer to me and makes the code much more readable. And anytime we can have more readable code, it's better. And it also makes it easier to add. So if I want to add one, I'll actually add the pair together, and then we can say, x 200, y 200, get a little Winston in the middle there. Cool. Now I want to show you something even fancier than this. Notice how our function right now accepts two numbers and then uses those two numbers. Well, we could change our function so that it expects an object and then it gets the x and y from that object, meaning that down here we could just pass the object. Let's try that. So we pass the object. Now it's broken. That's because our function still is expecting two objects and it's only getting one. So we'll change it to say it's getting face position. And now we get an error, which is face x is not defined, because before we were passing in face x as an argument, but now it doesn't exist. We're only getting an object. So what we could do is actually save the x position from the object inside the face x variable. So we're saying, okay, we got this object. We know this object has an x property, so we're just going to store that into the face x variable. And then we could do the same thing with y. So face y equals face position dot y. Ta-da! And then, the rest of the function, it uses face x and face y. Now we have to make sure we spell them correctly. If we did xx, it's not going to work because that's not what it is down here in our array of objects. So it needs to match. But this is pretty neat because now you can have arrays of objects, you can have functions that take in objects, and you'll really find that your programs can be very powerful with the way that they structure their data, and especially since it's so often to want to pair x and y together. I think you'll find them especially useful in all your drawing and animation programs here. So go to it and have fun.
In the English language, we have different parts of speech, like noun, adjective, preposition, verb, and then there are a bunch of rules that tell us how to put these different parts of speech together. So if I said something like dog, books, my, eats, you'd be like, what the heck does that mean? And if you didn't realize this before, apparently you can't just stick two nouns in front of an adjective in front of a verb. It doesn't work. But if I'd switched those and said, my dog eats books, then you would totally know what I meant. I could even replace this verb eats with another verb like, I don't know, throws, and it would still make grammatical sense, even if you can't imagine my dog throwing a book. So in programming, instead of parts of speech, we have these things called types. You've already seen one of these, numbers. We use numbers all the time in our drawing code. And just like in English, there are times when it makes sense to use a number and times when it doesn't. If I started typing in this background function, like 100 minus, then whatever comes next better be a number, or at least something that evaluates to a number, like 14 plus 15. On the other hand, if I just typed 100 space, well, I can't really put a number after that because 100 space 10, that doesn't mean anything. So there's another type in programming called the Boolean type. And it's called Boolean because some dude named George Boole invented it. And unlike a number, which has a ton of possible values, a Boolean can only be one of two values, true or false. And you can see when I type them, they turn blue, which means they're super special awesome words. And you've already seen one place where we use Booleans, though you may not have realized it. If statements. Let's get a quick refresher on how this works. I'm just going to make a variable called number, give it a number, like 40, and write an if statement that says if number is less than 50, then I will draw this first ellipse. So I'm just going to copy this into the if statement and indent it by selecting everything and pressing tab. So now this statement says if number is less than 50, which it is, then we'll draw the top ellipse. And if I make number greater than 50, you can see that the top ellipse disappears. Alright, so this thing inside the parentheses is actually a Boolean expression. Remember, a math expression is anything that evaluates to a number, like 3 plus 2 plus 4 times 8. So a Boolean expression is anything that evaluates to a Boolean. A good way to check if an expression evaluates to a Boolean is to stick the word is in front of it and ask it like a question. If it sounds like a yes or no question, then you know it's a Boolean expression. So here we can say, is number less than 50? Yes, yes it is. And yes, that is a Boolean expression. On the other hand, if I had something like 4 plus 4, and I tried to ask, is 4 plus 4? No, not a Boolean. So back to our if statement. I can actually put anything inside these parentheses as long as it's a Boolean or a Boolean expression. So I could say if true, and that ellipse would always be drawn, or I could say if false, and the ellipse would never be drawn. I could also do something like if 3 is less than 4, which is a Boolean expression that will always evaluate to true. Well, it's kind of pointless, but the ellipse will always be drawn, or 3 greater than 4, and that's always going to be false. And I can also assign Booleans to variables, like this. So I'm going to make a new variable, var, call it Winston is cool, and assign it a Boolean value, so true or false. Say true because Winston is definitely cool. And now that this variable has a Boolean value, I can copy it and stick it inside this if statement. And now you can see the ellipse is drawn because the value of Winston is cool is true. I could also replace this with a Boolean expression, so maybe 2 less than 4. Now, if you're making a variable that's meant for a Boolean value, you should give it a name that describes the condition when the variable is true. A good way to check if you've picked a good name for your variable is to put it in an if statement and see if it makes sense as a condition. So forget Winston is cool, we already know that's true. Let's say I had a variable called muffins. Alright, if muffins. Well, you know what? That doesn't tell me anything. So that's a pretty bad variable name. But if I had if muffins are baking, then that would tell me that when this variable is true, then the muffins are baking. And don't ask me what muffins, it's not important. So for now, let's just go back to if number is less than 50. Cool. Now let's look at some other Boolean expressions. You've already seen less than and greater than, but you can also check if something is less than or equal to. So let's try if number is less than or equal to 48. And we could also say if number is greater than or equal to 48. And if it is, we will draw this top right ellipse. Oops, and indent that. And if you want to check if two things are exactly equal to each other, you can say if number and then 3 equal signs, so triple equals 48. So that's a lot more like the equal sign that you're used to in math, except this time we have 3 of them in a row. It's kind of overkill, right? And then finally we have, if you want to check if two things are not equal to, so strictly not equal to, you can say if number and then an exclamation point and 2 equal signs, 48. And we will draw that last number is 48, so it is less than or equal to 48, which is why the top left ellipse is drawn. It's also greater than equal to 48. It's also equal to 48, but it is not equal to 48, which is why we're missing